Hi everyone, so today I'll be showing you how to solve this question 8, right? So yeah, I'll show you how to do it. So yeah, that's what they told us, that the battery in the circuit shown below has an EMF of 12 volts and an unknown internal resistance. Small R, the resistance of the connecting wires and ammeter is negligible. So now they say switch S is open. So yeah, when solving this part of questions, we have to remember that switch S is open. So for 8.1.1, say we have to write down the reading on voltmeter V1. So now let's look at our circuit. When switch S is open, there is no current flowing in this direction. Right, yeah, there won't be any current flowing in any of those wires. Right, yeah. So which means V1 will only be reading the voltage here. Let me mark it in red. Okay, so which means V1 is just reading the voltage around the battery. This is the only place where there's a connection. So which means now V1 it will read this voltage, right, which is 12 volts, as you can see it from this other side. So the next part says we should calculate for voltmeter V2. So now for 1.2, when you look at V2, where's V2? V2 is here. Remember that switch S is still open, so there's no current flowing here, so which means the current is 0. So which makes the voltage V2 to read 0 volts, right? Or if you're not sure about it, you can just try and substitute the 0 amps and then now solve for voltage, multiply that resistance, 6 ohm resistance with 0 amps, it will give you 0 volts. So yeah, that's how we get that calculation. So now let me just get the eraser. So now right on this part, they see now switch S is now closed. So and the reading on the ammeter, which is this ammeter, is 1.2 amps, right? This ammeter 1.2 amps, and then the power dissipated in the resistor X is 5.6 watts, right? That's the power. So now let's say define the term power. So yeah, I gave you the notes which has all the definitions that you need under circuits. So now just remind you, power is the rate at which energy is transferred. So yeah, that's the definition of 8.2. Now let's go to 8.3. So for 8.3, the same, you must get the resistance, you must calculate the resistance of resistor X. Right, so what do you know about the resistor X? We are given the power that goes with that resistor. We're also told that there's 1.2 amps, right? Yeah, since they said that this ammeter reading is 1.2 amps when the switch is closed. So this basically means that the total current moving the circuit is 1.2 amps. So since which means when the current moves, the current that goes through resistor X is the total current, since it is connected in series. And then since this is connected in series, which means the total current will be going through resistor X. There, so now we can use any of the equations that have power. So we have like three. right? We have, this one, I squared times R, and then we have V times I, and then we have V squared over R. So it's important to check what is it that we have. So in this case we have the 1.2 amps, and then we also have the power. So the easiest one to use is the one which has power and I for current. So when we have that equation, we just solve for R, right? So for those who are not good with algebra, I'll just write this other method that I skipped after the. So when you have P is equals to, sorry about that, P is equals to I squared times R, right? Remember that we want to solve for R, so we're going to divide both sides by I squared on the side, I squared, and then that and that cancel. So now you'll be left with P over I squared is equals to R, right? So that's how you can get your resistance. You can just simply write it on the other side and say R is equals to P over I squared. So when you substitute those values, the value for P, right, let me just remove this part. So the value for P, already have it, which is 5.76, and then the value for I, we already have it also, it's 1.2. Remember the squared outside, right? So now when you do that, you're gonna get your R as 4 ohms. So another way which you can use, you can still use this other equation, because you have P and then you have I, just that it's going to be a bit long. In this case, you'll have to use that equation to get voltage, and then from voltage you can choose which equation you want to use to get your R, right? So if you use that equation, you're just going to substitute what we have, which is the power and the current, and then it's going to give you a voltage of 4.8, and then from there you can choose whether you use this equation or you use this one to calculate the value of R. So those are the different ways that you can use, or different methods that you can use to solve this question. So now we'll move to the next one. The next one says we should calculate the total resistance of the circuit, right? So which means this is what they want. They want us to calculate the total resistance of all these resistors. Resistor X, 2.4 ohm, 6 ohm, and also that 6 ohm. This and that, right? So that's what we're going to do. So right, it's important for us to know how those resistors are connected. This one is in series, and then this one is in parallel with this ones, right? Take note that the current flows this way, right? And the current is not going to go that side, since voltmeters have high resistance, right? So it's like this one and this one, they're connected in series, but they are in parallel with this. So now this is what we're going to do. We're going to calculate the parallel side first. We're going to say 1 over Rp is equals to 1 over R1 plus 1 over R2. Right, in this case R2, it represents the sum of these two, right? 2.4 plus 6 ohm. And then once we have that, we're gonna do everything to the power of minus 1, because remember we are looking for Rp, not 1 over Rp. And then after doing that, this is what we get 3.5 ohm, right? But yeah, remember that this value is just for parallel, so we still need to get to add the resistance in series. And remember that from question 8.3, when we calculated our resistance, we got 4. So this is what we got, 4, right? So it means resistor X is 4. Just keep that in mind. So now we're going to see resistance in series plus resistance in parallel, and then now it gives us 7.5 ohm. So now we go to question 8.5. right, since yeah, we already have the total external resistance of the circuit. So in total, in question 8.5, now we have to calculate the voltmeter reading on V2, right? So now this is what's going to happen. This one is a bit tricky, but I'll break it down in such a way that you can understand. Right, so when we have to deal with this question, right, we'll find a way to get at least something from here. So far we just know that we have this current of 1.2 amps, and for this resistor we know the current passing through here, we know its resistance, so yeah, we also know its power. So this is what I suggest we do. So yeah, remember when you have what is it called, when you have EMF, right? When you have EMF, this is our equation for EMF, which is equals to V external and V internal. V external will be the voltage from resistor X, right, plus the voltage in parallel. So it basically means it's voltage V external, it's voltage from resistor X and voltage in parallel. And in parallel, if you have this V parallel, right, let me try to erase and write it somewhere here. So so 6 ohm will have that VP, right? Whereas, and then in this side, the total voltage of these two resistors are connected in series, but they are parallel with this. It will also be equal to VP, right? So VP is also equals to the voltage of 2.4 plus the voltage of 6 ohm. Hope that makes sense. So VP is equals to V for 2.4 plus the voltage for 6 ohm. So yeah, keep in mind that those are the properties of circuits. So just remember that in parallel the current divides, right? So which means that 1.2, it divides here, and then part of it will go this way, another part will go that way. And then in series the voltage divides. That's why those two will have the different voltage, but the current is the same. And with the parallel, the voltage is the same, the current is just different because it divides. That's why here we're going to have VP, and then on the other side we're also going to have VP. So the sum of that voltage will be equals to VP, because this side is parallel to this, right? So if you had one resistor, if you had one resistor, let's say maybe this was not there, so which means the voltage here would be VP, and then this one will also be VP, right? But yeah, now since we have two and are connected in series, which means the sum of the voltages will be equal to the other parallel side. I hope that makes sense. Right, so yeah, with that in mind, remember that we already have the total resistance that we got of 7.5. We already have the total current of 1.2 amps. So, and remember that this total current is basically like, it's like R externals, the external resistance, right? It doesn't include the small r. So now, which means you can use the external resistance, the total external resistance plus the total current, right? And then now that will help us to get the external voltage, right? So that's how we get our external voltage, by multiplying that 1.2 with R, which is, this is our total current multiplied by our total resistance, and then this will give us 9 volts. So now we have total resistance, we have total external voltage, right? It's not internal. So now when we have that external voltage, remember we said that external voltage is equal to the voltage Vx plus Vp. So we already have V external, so we can get Vx. Remember that for this we said we know the current passing through here, which is 1.2. We know the resistance, which is 4 ohm. So yeah, from that we can get our thing. Let me see if I didn't leave it out. Okay, right, yeah. Okay, so this is the equation that I used. So I said P is equal to V over I, right? So this is for this resistor. Remember, my aim is to get the voltage. So if I can get to Vx, which means now I can narrow the problem. And since I will have V external and Vx, so I can just subtract Vx from V external, and then that will give me V parallel. That's what I'm trying to do. So yeah, solving for V using this equation, I substitute my power is 5.76 watts, and then the I, it's 1.2. Then since I don't want V 1.2, I want V, I divide by 1.2, so this cancel, and then I'll be left with V is equals to 4.8 V, which is like the value of Vx. And then now, right, since we have Vx and V external, which is this one, it's 9. We calculated it here. So I'm going to now subtract 4.8 from 9, and then it gives me 4.2 V volts, which means now the voltage in parallel, that Vp, is equals to 4.2 volts. So which means if we add the voltage of this one and the voltage of this one, it will give us 4.2 volts, right? So yeah, if you're struggling with algebra, this is how you can do it, right? So yeah, you basically take the Vx to the other side, it will have a negative, that's why you have negative 4.8, and then you solve it that way, right? So now, since we have the V there, right, this is what we can do. We can find out how much current is going this way, since like we already have two things in this direction. So if you can find out the current that's going here, we can take that current and then subtract it from this 1.2, then we'll know what current goes in the other direction. So if we know what current goes in this direction, then we know that the current even though this part is parallel to this one, but that current will be in series with these two resistors, therefore which means the current here will be the same current here. So if we have a current and a resistor, we can now get voltage. Remember, R is equals to V over I, so which means we have V and I. We can get we have R, and so we have R and I, so we can get our V, which is V2, what we're looking for. So yeah, now to get the current, I'm using that equation. So here I'm just showing you how I got to make it in terms of I, right? So just divide it, I first multiplied, right? Multiplied out with I, because I want this and that to cancel, right? And then I'm left with Ri on the other side. I don't want Ri, I want I, so I divide everything by R, so this cancel, so I'll be left with I is equals to V over R. Now remember, we are calculating for this part, so we're going to use VP. We want to find this I, this side. So now that VP is equals 4.2, so I'm going to divide it by 6 ohm, which is the 6 ohm. And then I'm going to get 0.7. So which means 0.7 went this way, and then the remaining went on the other side. And remember that once the current moves, when it gets here, it will be 1.2, right? It just divides when it goes through the parallel side. But yeah, when it gets to the part of the circuit which is in series, it sums up into 1.2. So which means now I can use this 0.7, right, which is the current on I6 on the 6 ohm resistor. So I wrote I6 there, and this is the 6 ohm resistor that I'm referring to, not this one. So now I can say, okay, from the total, let's subtract that 0.7 so that we can find out how much current goes on the other direction, and then we're going to get 0.5 amps. That's the current that goes through 2.4 and 2.6 ohm. That's why I wrote that. So since now we have the current that goes to 2.4 and 2.4 and 6 ohm is that. Now we can just use that current and check how much voltage you have there, right? So yeah, and then I'm just gonna use that equation and then make it in terms of V, right? That's how I do it. So if you're struggling with algebra, I'm just gonna explain it again. So we want V, so we're gonna remove I by multiplying both sides with I, and then this I and that I will cancel, so I'll be left with Ri on the side, and then and on the other side I have V, which is what I want. So I just swap this and this, like same thing. So I just swapped them just to simplify the equation, and then make the equation in terms of V. And then now when you when you substitute the value, remember we are trying to calculate the voltage for the 6 ohm, right? And then the current is 5, and remember this is the same current that goes through here. So when you do that, this is what you're gonna get. You're gonna get 3 volts, right? So just to check if this is true, like the voltage here and the voltage here will give you VP, you can work out that other one, right? So I'm just gonna use this part of the equation. So let's try to get the voltage of that 2.4, right? The resistor is 2.4, and then multiplied by 0.5, and then when you do it on your calculator, you get 1.2 volts. So when you add 3 plus 1.2, it will give you 4.2, right? It will give you 4.2, which is the VP that you got. Remember, so that's what you're gonna get, 4.2. So this shows that what we said is true, because remember we said VP is the total voltage in parallel on each side, right? VP, this is equal to VP, and then the sum of the voltage of these two resistors will give us VP. So yeah, so here we proved it, because 1.2 plus that is equals to 4.2, right? So yeah, I was just showing you this part. You're not supposed to do it. I was just trying to show you what I meant by this part. So now, yeah, that is it for the question, right? There's many ways to do it, but yeah, I think if you can understand this way, you will be able to try out different methods. This way, I think, is the easiest part. Yeah, it's a bit long. So yeah, you're welcome to try other methods just to see if you can arrive at the same answer. So now for 8.6, they're telling us that a length of wire, or a length of wire of negligible resistance is used to connect point P to Q. Right, so now this is what they mean by that. I'm just gonna try to draw the wire here. Right, so yeah, this is the wire, connects that side. So now, this is what you have to know about current. Current is like sort of taxi drivers. So you're just gonna use that as an example. So let's say there's a roadblock. When there's a roadblock, it will try by all means to use the route that doesn't have roadblock, unless if they don't have a choice. So in case, as you see here, they don't have a choice, they have to pass here, whether they like it or not. So yeah, similar to current, it will come here and it'll see that, oh yeah, there's too much resistance this side, so it will use the route or the wire with less resistance. So which means now there won't be any current flowing in these three resistors. So it's like these resistors are not there at all. Let me see if I can get something to highlight. Okay, I was trying to find out if I can have the the white color, but it's fine, it's not there. So yeah, okay, let's try to make it a bit thick. Yeah, so it's like this. Resistors are not there. Right, for this case, I'm gonna take it like that, like they don't exist, since no current is gonna flow through that. Right, so let me take it back to it. Okay, so now we want to know that if this case happens, what will be the reading on voltmeter V1? Remember, the current will be just flowing in that way, so it's just like there's a straight wire. And remember, you calculated our total resistance. Our total resistance, we said it was 7.5. Yeah, here, right? External resistance, it was that. So now, if those if there's no current flowing in those other three resistors, which means now the external resistance is now 6 instead of 7.5. So what is it that happened to the external resistance? The external resistance decreased. Since it was 7.5, now it's going to be 6, right? And remember that this value of external resistance did not include the small r, right? So which means the external resistance, it decreases, right? So when they're using this, R is equal to V over I. When external resistance decreases, the external voltage will also decrease, since they are directly proportional, and the total current would increase, right? So remember that when the circuit is connected, V1 reads the external voltage. So this is what they want to know. They want to know what will happen to V1. So V1 is equals to the external voltage. So since we know that the external resistance decreases, V1, which is the external voltage, will also decrease. So that's why we say decreases. We're gonna choose that option, right? And then so this is how we explain the answer. Say we're gonna first say it decreases, and then it's part of the explanation. Total resistance decreases, and then the current increases. V let me start with this one first. V external decreases, as you saw there. So the reason why V internal increases is because EMF is constant, it doesn't change. So which means whenever there's a change in one of those two, either V internal or V external, the other one has to cater for the change. So in this way, in this case, since V external decreases, which means V internal has to increase to keep the balance, so that this value can remain 12 volts, which you got there. So that is it for this question. If you still don't understand anything that I said, feel free to leave the question in the comment section. I'll try to answer your questions to the best of my ability. Thank you.